All right. Thank you for joining us this morning for our live demonstration on the updates made in FortiOS 6.4.0 to our switch and wireless product. My name is Soraya Tati, and presenting today is Secure Access Engineer Jim Wang. Jim and I are part of an overlay team here at Fortinet supporting the switch, access point, and 3G and 4G backup technologies. We do have a lot to cover today, so we're going to be responding to your questions in a follow-up email. You can either submit questions in the chat or email them directly to me. In one of our previous sessions, we discussed our remote access point. That's our C24JE for the remote workforce. And we've gotten a lot of interest around this solution. So we're extending special pricing on these access points. And if you're interested in learning more, please contact your local Fortinet rep. We do have an upcoming webinar on May 6th, where we're going to be reviewing FortiManager and FortiAnalyzer and their integration with the Secure Access products. If you want to see more on the Fortinet Secure Access product line, please send me an email and we can work to schedule a meeting with our team. A recording of this session, previous sessions, as well as a registration link for our upcoming webinar on FortiManager and FortiAnalyzer will be sent out after this demonstration. So with that, I'm going to go ahead and hand it over to Jim to take it away.
Thank you, Soraya. Hello, everybody. I'm glad that I'm able to provide you guys with a demo of the new secure access features that has been introduced with FortiOS 6.4.0. In today's demo agenda, I'm going to do a comparison between the FortiLink interface from a previous 6.2.3 release and the latest 6.4. We're going to go through an example of creating a VLAN and also configuring switch ports to the new VLAN. We're going to glance through the new managed FortiSwitch view, see how that's been changed. We're also going to look at the quarantine feature, how we're now doing the quarantine by default over redirect as opposed to by VLAN, and then I'll have a demonstration of quarantining both a wired and wireless client. We're going to look at auto firmware upgrade and how we're adding yet additional zero-touch deployment features to managing your FortiAPs. And then additionally, we're going to take a look at the new Wi-Fi dashboard and the new Wi-Fi client view. And last but not least, we're going to look at the new troubleshooting capability of our FortiAPs, where we're able to enable them to do spectrum analysis. So with that, let's go ahead and get started. So as you can see here, I have a FortiGate GUI that is running 6.4.0. The FortiGates that I have running FortiOS on is a pair of FortiGate 501Es, kind of medium-sized FortiGate firewalls. We're going to look into features underneath the Wi-Fi and switch controller, and really always a comment worth mentioning is that every single FortiGate firewall comes built-in or integrated with the Wi-Fi and switch controller without any additional licensing. So in this first demonstration, we're going to look at the FortiLink interface, and you can see here that it's already been configured on this FortiGate, where you have an aggregate interface that's being used by FortiLink, two interface members, X1 and X2, which in this FortiGate model happens to be two 10-gig interfaces. We have, of course, an IP address. This is actually a new feature in the FortiLink interface configuration. In prior releases, the DHCP server configuration was hidden. So now that it's exposed, you can actually set up static DHCP reservations if you want to do that, and it's actually now possible in the GUI, where previously it required the CLI to make those configurations. NAC settings, this is actually also a new knob to the FortiLink interface. It's new because NAC as a feature is new to FortiOS 6.4.0. And if you're not familiar with NAC, it stands for Network Access Control. So with FortiOS, it now has the ability to support network access control policies where for devices that are actually plugged into managed FortiSwitch ports, the switch controller is capable of detecting and classifying those devices based on details such as user group, MAC address, vendor type, device family, device type, operating system, and username. And with those details being used to identify the device, the FortiGate on configuration through NAC policies can dynamically assign those devices to their own VLAN or apply a 802.1x security policy that further puts them into the appropriate network and allocates whatever necessary network resources those devices would need. This is very similar to the capabilities that we've called universal port through 802.1x previously. So NAC is actually a great feature, and it also actually makes an exciting topic that which I won't actually be doing a demo on today, but it is such an excellent topic that really deserves a webinar all by itself, and we plan to have that in an upcoming webinar. So as you can see here, with the FortiLink interface already created, and with my FortiGate already having switches behind it, you can actually see that there's a total of 12 switches that's connected behind this aggregate interface. We're all set to go. So really the next step is for us to go through the example of creating a VLAN, and I'll just go ahead and run through a VLAN creation really quickly because this step hasn't changed all that much. I'm going to go ahead and create a data VLAN, give it an IP address, allow it for pings, and have the FortiGate perform as a DHCP server so that it can allocate DHCP to hosts that are on this new VLAN. And actually what's worthy to note here is this feature that says create address object matching subnet. This is actually as you can see here, by default it's turned on. So a great feature, not a feature that's been added in the new 6.4 release, but it's been added in a 6.2 release actually. So it really actually saves a lot of time because during the step where you're here creating the data VLAN or the new VLAN, it goes and automatically creates an address group under policy and objects where that address group can be used for a firewall policy, in particular for that data VLAN that you've created or that new VLAN that you've created. So I'm going to go ahead and hit OK on this and have the new VLAN saved. So at this point, we can go ahead and go into FortiSwitch ports and configure some switch ports to operate as an access VLAN to that new VLAN. Okay. And really, this process hasn't changed all that much either with 6.4. For those folks that that actually have a lot of switches and they find it cumbersome having to kind of, scan through all of their FortiSwitches and FortiSwitch ports, what I wanted to show you here with this step is just a tech tip. Use this search or filter box up on top, and you can actually feed in the friendly name of your FortiSwitches, say that you have, a number of switches within an IDF closet and you want to go ahead and configure those switches, then you can go ahead and put in the name of those switches, the friendly names that is, and then feed that in here, and the GUI will show you just those switches and the switch ports that is underneath those switches. So in this particular case, I have 4 switches within the IDF3 closet, and each one of these switches are 24 ports. So I want to go ahead and configure all 96 of those ports. Just as a first example, here's what it's required to configure just a single port. I have port 1 highlighted here. I'm going to go ahead and set the access VLAN to the new data VLAN. And your typical office or campus use case might actually have a voice over IP phone where you need to allow voice traffic on that port. So this is where you can, along with assigning an access VLAN, you can, with the port already highlighted, you can click on the edit box under the allowed VLAN and add the voice VLAN as well. So now if I wanted to go and make that configuration change across all 96 ports, it's really just as easy as selecting all 96 ports and doing the exact same thing. Access VLAN data and adding the voice VLAN as an allowed. So with that step, you're pretty much done with the switch port configurations, and you're at a point where you can plug in, your workstations, your laptops into these switch ports. But there is actually one more step that's needed before those hosts are able to pass traffic while on the this new data VLAN, and that is the firewall policy. So without actually creating a firewall policy for the data VLAN, because this is a next generation firewall that is acting as the layer 3 for all managed VLANs, all traffic will essentially be dropped from passing any layer 3 because of this implicit deny rule. So that's why we need to create a policy that allows for this new data VLAN to maybe get out to the internet, or even pass traffic or forward traffic to VLANs that are over the layer 3, different VLANs that are on the internal network as well. So in this case, I'm going to go ahead and real simply create a data VLAN that allows for those hosts to forward traffic out to the internet through the FortiGate. So my incoming interface would of course be the new data VLAN. The outgoing interface would be the WAN port and source. And this is where that nice new feature that automatically creates the address group comes in handy. So we can now look for the data VLAN or the data address here without actually having to, be lazy and selecting all. This really allows us to maintain our high security stature and use that subnet range that's been allocated under that particular VLAN. Destination, of course, is all, and service, we could selectively choose a number of these things, or in this case, I am going to be lazy and select all. And of course, NAT needs to be enabled for any internet-bound traffic, and it's always recommended to enable some UTM security features as traffic is going out to the internet. You want to make sure that that traffic is being inspected with some of these UTM features. So that's what the firewall policy looks like. And let's take a look at the next demo. Let's look into enhanced managed FortiSwitch view. Also under Wi-Fi and switch controller. Now, at first glance, you'll look at this topology view and notice that there definitely are significant changes with 6.4 and the topology view. No longer do we have the individual FortiSwitches represented by their faceplate and all of the various colored lines that are connecting switches to other switches. This is really, with this new release, we simplified it. Each of the switches are represented by their own box, and it's only those switch ports that are being used by FortiLink that are displayed. Really kind of keeping it very simple. We also introduced a legend on the lower left here that shows us the different types of links. A black line representing just a regular interswitch link, a dash line representing a interswitch link that is currently disconnected, a orange line that's representing an ISL link that is through STP is at a blocking state. And then, of course, the turquoise blue line, which is a ISL link that is actually in between two FortiSwitches that are MCLAG peers of each other. So we actually call that particular link an ICL, or an inter-chassis link. So in this particular topology, I have a pair of MCLAG switches on the very left here that are connected to my HA FortiGates over 10 gig. And I also have a second tier MCLAG as well. And there's actually a lot of great detail by doing mouse overs over these links. We're able to see the two switches at each end, what ports are being used by those switches, the friendly names of those switches, the speed of the link, and the STP status. And also what's nice is it also provides you with transceiver information that's used at both ends of those links if they happen to be a fiber link. Now this is actually an interesting topic here. In my topology, I actually have a stacked ring. In prior releases where we have a stacked ring configuration, we'd actually had each one of these links show up as being connected. Now with 6.4, because this is actually a loop, the GUI is now able to display that link that through FTP, in order to prevent the loop, FTP has changed the status to blocking or discarding in this case. So as you can see here, as we have distribution switch 2 connected to IDF 3.1, 3.1 connected to 3.2, 3.2 physically connected to 3.3, and 3.3 physically connected to 3.4, and lastly 3.4 completing the ring, providing HA connectivity to distribution switch 1. This is a loop, but spanning tree took the link between 3.2 and 3.3 and made it blocking to prevent the loop. So I actually have a quick demo here to show you where I can actually, through configuration, make this link 3.1.2.3.2 less attractive, essentially setting the STP cost to that of a 100 meg interface as opposed to a 1 gig interface, which these links are all 1 gig links. So let's go ahead and see how quickly the GUI is able to update its visual, reflecting that this link will no longer be blocking because it's going to be more attractive with the higher link, where this link will be less attractive and now become the blocking. So you can see that change happened pretty quickly. And the GUI itself was able to accurately represent the actual state of the spanning tree network, where now this link here is blocking because it has a lower STP cost. And actually, another couple of views that's been released with the managed FortiSwitch is the list view. So this is a really nice view in itself as well. I actually have more switches than that. It's because I have a filter. So let me remove the filter so that we can see all 12 switches. So this is very similar to our existing FortiAP view, where we have the list of all of our switches, their status, their model numbers, their IP addresses, when they joined. In this view, we also introduced switch group, where we could create a FortiSwitch group and include switch members in it. Really what it allows for is just a logical grouping of like switches together. You might actually have multiple switches within your MDF, multiple switches within your IDF, a couple of distribution switches. So it's good just for manageability to be able to create that logical grouping. We also support groups within a group. So in my example, I included building as a group. So building 1 has lots of switches underneath it, including the distribution switch groups, the IDF and NBF switch groups, and I can actually give you an example right here. We could toggle the switch group column, add a filter that says, hey, I only want to see those switches in building 2. And in that case, building 2 is just a warehouse, and it only has a single warehouse switch. Let's go ahead and take a look at those switches in building 1, and also just my IDF3 switches. So in that case, did I select that right? Building 1, well, actually, because I selected building 1, it included all of the building 1 switches. So here we go. And this is all of the building 1 switches. And if I wanted to just see the IDF switches, I would just select the IDF switches. And this is, again, just another capability that allows you to just see those switches that you're interested in managing at this time. And as it's now displayed on the GUI, you can go ahead and perform management tasks such as upgrading software, maybe viewing its individual switch ports configurations. And actually, this is a nice view. And let me go ahead and remove this, and we'll drill down into this switch here. And what we can do is do a show ports. And while I mentioned that we took away the faceplate from the topology view, it really just got moved to a different location within the GUI. So under FortiSwitch ports, or excuse me, under Manage FortiSwitch, we could toggle to a particular switch, drill down into it, and open up its faceplate tab. And in this case, you'll see a given switch that I selected. You'll see the VLANs that's available up on top, represented by the color and the name of the VLAN, which the color is actually represented on the switch ports. So green, you know, you can actually just look at, without actually having to do a mouse over, you can look at it and know exactly what access VLAN those ports are on. So these 5 ports are on the UserNet 1 VLAN, and the rest of those ports are on the guest VLAN. And of course, the little lightning bolt or electrical symbol, you can do mouse overs on them, and they're just showing us that those ports are currently providing PoE to PoE devices such as access points. And if we do a mouse over on them, we can get the real-time PoE usage as well, and a lot of other details such as link speed, you know, the same access VLAN and allowed VLAN details. And then lastly, there's a groups view, which is really just a view that shows all of your logical FortiSwitch groups, and you can actually drill into each one of them and edit them, add members, remove members, and just make those necessary configurations. Okay. Before we actually kick off the demo of quarantine, we should really run through a little bit of history on quarantine and the feature itself. So by far, the most common use case for quarantine is with indicators of compromise. So indicators of compromise is a service that we have through multiple Fortinet products that allows for the FortiGate to be able to identify hosts that are compromised. So those compromised hosts are actually identified through indicators of compromise by taking a host's web filter, DNS, and traffic logs and having them checked against a threat database, where through the threat database, it's determined that the host is an actual threat. So now that we have IOC, or indicators of compromise, being able to identify those compromised hosts, the recommended approach is to have those compromised hosts automatically quarantined, really being able to take a proactive approach to not having those compromised hosts and the malware spread across the rest of the network. So with that, let's go ahead and just do a quick demo of how you would actually set up that automation of taking those IOC determined compromised hosts and being able to perform auto quarantine on them. So that actually is done under the security fabric, under the automation, and this is where we can go ahead and create a automation stitch that says auto quarantine compromised hosts. And the trigger, of course, is IOC and the service determining or identifying those compromised hosts. The action is you can actually have one or several. Maybe you want to actually have, upon a compromised host being identified, an email being sent by the FortiGate to your security team notifying them of a compromised host, just to support the proactive capability of not having the malware spread across the rest of the network, and really as quickly as possible having that host quarantine at the FortiSwitch port. You can enable access layer quarantine. Then lastly, maybe you want to kind of make sure that you have an audit trail of that compromised host and make sure that your security teams are properly remediating it, making sure that a service ticket is open. So the webhook allows you to maybe tie a REST API to like ServiceNow and have a ticket created so that your teams can work on having that host remediated quickly. So this is what that automation framework would look like when you are taking a IOC identified compromised host and automatically performing these actions once you have that trigger. Now, in my particular case, for the demo, I actually have a couple of VMs that I want to show quarantine redirect on. And even before kicking off the demo, we should talk about the differences between the quarantine feature that was under previous releases and how quarantine actually works now. With 6.4, the default quarantine behavior is to use the redirect. And that actually is, in my opinion, a nicer method compared to the previous method of quarantine by putting the compromised host on a quarantine VLAN and isolating them because that quarantine VLAN has no access anywhere. The problem with the quarantine VLAN is, while it completely isolated the compromised device and really prevented it from having its malware spread across the rest of the network, because the host got put onto a separate network, it required the host to get another IP address, which as a result makes it difficult to track the host. And this is where the new method of redirect alleviates that, because with the quarantine redirect feature, the host is maintained on the original network that it's on, and really the way that the host is being blocked, it's through its MAC address. It's actually the FortiGate keeping track of the host's MAC address, and if it sees traffic from that particular MAC, it will no longer allow that host to be able to pass traffic. And I'll go ahead and show you in detail how that works. So with 6.4, again, quarantine is done through redirect, and then the way that works is with this release, under policies and objects, it goes and creates a address group called compromised device, or excuse me, quarantine devices. Okay, so whenever especially if we're leveraging indicators of compromise and automation, when a compromised host goes through an automation stitch and has that host get put into quarantine, its MAC address will automatically show up under the quarantine devices group. And while this new feature under 6.4 automatically creates the address group, we still need to create a firewall policy that uses that quarantine devices group that says, basically, if you have a host, or if you have traffic coming from anywhere, going to anywhere, coming from a quarantine device's MAC address, I want you to drop it. And that's exactly what this firewall policy does. So you'll need to create this in order to support the quarantine by redirect. So with that, we can go ahead and kick off this demo. And as I said previously, I have a couple of VMs here. One is a wired host, One is a wireless host, and you can actually see just based on the network connection details on the lower right of each that, again, one is wired and one is wireless. Now there's a number of pings that's being continuously run on these different VMs. On the wired host, I have a ping that's to a local layer 2 host, okay? And there's a separate ping that's actually pinging Google's DNS IP address. On the wireless host, there's only a single ping that is pinging Google's DNS server. The reason why I don't have a L2 ping is that this SSID is already blocking intra SSID traffic. So if I were to kick off this wireless host to be quarantined, it would have been blocked in the first place, or L2 traffic would have been blocked in the first place. So with that, what I'm going to do is go ahead and manually quarantine those two hosts, and we'll go ahead and see what happens. So I'll start off with the wireless client. There's really multiple places where we can initiate the quarantine. Under Wi-Fi and clients, I can actually, let's see, I do have some notes here. Wireless host is bking PC, where bwarren host is the wired. So here it is. I can feed in the host name here, and I'm able to quickly identify the host. And you can see that when I do drill down into the host, I do have a quarantine option. So let me go ahead and kick off quarantine of the wireless client first. And then for the wired client, the best place to do that is through devices here. And I'll also go ahead and search for this device, drill down into its FortiView details, and then as an action, I do have a quarantine. So now both my wired and wireless hosts are quarantined. Let's go ahead and see what the result is of the pings. And you can pretty much see that the pings have ceased. And really, the goal is to check and see whether its IP address has changed. And you can actually do an IP config, and it hasn't changed. The lease was obtained quite some time ago, and we could see that we're also still able to ping the FortiGate. It's just that we're not able to ping beyond the FortiGate. So again, redirect feature, different from the previous implementation of quarantine, which is moving these hosts to a quarantine VLAN. Likewise, this would be the same. We could ping the FortiGate fine, but not beyond the FortiGate. So let's go ahead and assume that we've now remediated the hosts, and we're going to go ahead and remove their quarantines. So another place that we can do that at is under the dashboard, users and devices, under quarantine. But actually, before we do that, I wanted to show you that policy quarantine device address group. So you can kind of see how this feature is actually being done. We talked about the quarantine devices, and we talked about how when a quarantine is done on a device, their MAC address is actually put into this device group. And that's exactly what you see here. Two quarantine MAC addresses, one for the wired client, one for the wireless client. And as a result, it's the firewall policy for quarantine devices that's preventing those hosts from passing traffic through the FortiGate. Okay, now let's go back to the dashboard and remove their quarantines. And this is actually a nice view that shows all of the hosts that are actually under quarantine. So really simply, we can just go to each one of these and remove the quarantine. And we can go back to the VMs themselves and see if traffic continues. And there you go. Very quickly, we can see that traffic is recovered. Okay, so auto firmware upgrade for new FortiAPs is really the segue that takes us into our wireless features with 6.4.0. So with this, it's a relatively simple concept. We have FortiAPs that's being managed by the FortiGate already. What I have is a plan to install 2 more APs across my office because I've gone and actually expanded and taken up more office space from this building as my company is growing, and I need to install a couple new access points. And the goal is to be able to plug in these new access points and have the wireless controller, before actually having the access points go into service, have them upgraded to the latest recommended release, and then go into service and start allowing clients to connect to them. So where you actually see now, I have a couple of clients that I'm going to use for this demo. They have a notification on them already indicating that there's a new firmware version available through FortiGuard. They're currently running a 6.0 build 0037 release. The latest release is 4.4. So instead of actually manually upgrading each AP myself, I'm going to go ahead and have the wireless controller do the upgrade automatically. Now the step to do that is rather simple. All you need to do is actually upload FortiAP images into the FortiGate itself. And to do that, all we need to do is run the following command to get a FortiAP image upgraded or uploaded into the FortiGate. The command is execute wireless controller upload WTP image, and then you have the option to FTP it or TFTP, and then the next argument is the FAP software file, and then of course the FTP or TFTP server IP address. So upon hitting enter on that, the FortiGate is quickly able to download the software, and just to verify that the software is there, you can do a execute wireless controller list WTP image, and there it is. It's actually on the FortiGate itself, ready to be used to automatically upgrade the FAP 320C access points. So to simulate a new discovery and new authorization of these 2 access points, all I'm going to do is get them deauthorized and deleted, and then also reboot the PoE switch ports that those access points are plugged into. So I'll go into FortiSwitch ports, click on my port view here, And I actually did include friendly names to those individual switch ports that has those two APs plugged into them, and I'll go ahead and do a reset PoE. So this actually would then reset the access points, and what should happen is the AP will get discovered by the wireless controller. The wireless controller will, because it has the the FAP image installed in it, it will actually upgrade these two FortiAPs to the 0044 release, and then finally have them authorized and put them into operation, ready to service clients. So while it's going through that upgrade, it's going to probably take 2 or 3 minutes. We can go ahead and dive into the next demo. New Wi-Fi dashboard and Wi-Fi client view. So the Wi-Fi dashboard in 6.4 has been put into dashboard, and this is actually a great place for it. Prior to 6.4, we had different Wi-Fi views that was under monitor, and in other places under Wi-Fi and switch controller. Now it's nicely consolidated under the dashboard section, and even in quite a bit more detail. So in this particular view, you can see that we have a total of 8 different views that will give us FortiAP status, channel utilization, clients by FortiAP, signal strength, rogue, historical client count, and interfering APs, and even login failures. And each one of these, you can actually drill down and expand and get even more detail. You could move these windows around, resize them. So this is really at a point where you can use this dashboard view for Wi-Fi and have it maybe even projected in a network operations center, providing the teams an overall health of your wireless infrastructure. So a really nice addition to FortiOS 6.4.0. So we can actually, let's drill down into clients by FortiAP, which is actually a really nice view that is probably more popular than the other view, especially if you're wanting to do client troubleshooting. So here we are under the Wi-Fi dashboard view. We looked under the clients for FortiAP to see what the breakdowns of which clients are connecting to which APs, and we were able to actually drill down to an individual client and see the current applications that's running on the client. Maybe if we wanted to figure out, because there's been reports by the client that they've been experiencing a lot of disconnects, we want to be able to look at the client logs to see whether or not the client has been hopping around between various APs. So here we can look through the logs and see that, hey, we started off with the client being connected at one AP, and then later it roamed to another AP, and so on and so forth. Oh, look at here, it has a problem with failed authentication. So there's lots of ways we can actually use this view to effectively troubleshoot wireless connections from clients. And actually, this is the same capabilities that the Wi-Fi client view is going to give you when I open that up under the Wi-Fi and switch controller. So historical clients is pretty cut and dried, not much more detail in that one, but rogue APs would give us all of the rogue APs that are seen by different access points that's being managed. So we can see quite a bit of detail here. And for these rows, we could actually accept them as a rogue so that they could be properly reported. So just lots of great detail that we can get from this new Wi-Fi dashboard. And I think I mentioned that these could actually be resized as well if you want to make it even bigger. Now the other view is the Wi-Fi client view, and you kind of got a chance to see a glimpse of it from the Wi-Fi dashboard. So this gives you, again, all of the clients that's currently connected across all of your access points, details such as the SSID that they're connected at, their AP, the type of device they're at, they are, operating system, their IP address, and actually each one of these values can be searchable. So if you wanted to do a search of, all of your Windows clients, you can just feed Windows in here. All of your Linux clients, you can feed Linux in here. You can actually, do iOS as well. So pretty powerful. Signal strength is great information. The channels that they're connected to. If we're doing WPA2 enterprise authentication, user information is displayed on this table as well. And in fact, there's a lot of other columns and information that you can choose to enable as well. So a very visible tool here that provides a lot of information. And what's really exciting about the Wi-Fi clients view is that we now have the integration with FortiView. So if we want to drill down again to, you can get a list of applications that's currently running on the client. The destinations that there's existing TCP or UDP connections to, and also the current firewall policies that the traffic is currently using. And again, those same logs that allows us to do effective troubleshooting on authentication issues that the client might be having or disconnect issues, so on and so forth. We're able to look at, specific client logs pertaining to that client. And of course, we also have added features that I've showed you before, where we can quarantine the wireless client manually. You can disassociate them. There's an indicators of health that shows you the signal strength, the signal to noise ratio, and also the frequency or band that the client is connecting on. Details here are nice too, with the FortiAP channel, IP address, really everything that you need to know about this client. This is a kind of a historical bandwidth line chart that shows the usage within the last minute, the SNR within the last minute. And if you wanted to actually see details for, let's see, actually it's here. Under applications, we can actually see details now or details for the past hour, details for the past 24 or 7 days. So really, combined with FortiAnalyzer, you're able to present all of this information from the Wi-Fi client view on a particular client. So really, really powerful. Okay, so now that we're done with the Wi-Fi client view, let's go ahead and take a look at our AP that we've performed the auto upgrade on. You can see that here that they're back online, and then they're actually running the latest and greatest 6.0.4.4 release, and through the auto authorization that we have configured, they've been configured to already start broadcasting a couple of SSIDs for each one of the radios. So they're ready. They're ready to actually start accepting wireless clients for connectivity. At this point, I may want to go ahead and edit them and add friendly names, Office 6, and also Office 7. And that really completes the deployment of those two new access points. Now the next demo is our last but not least, which is the wireless spectrum analysis visualization. Now this is actually a new feature to 6.4 as well. It actually requires APs that are the REV-Es, such as the FAP 421E, the FAP 231E, and really a number of newer REV-E models. It also actually requires the 6.4 releases on those REV-E access points to be able to support this feature. The way that I would actually go ahead and have them configured is, because it is really more or less a troubleshooting tool, what you'd want to do is create a FortiAP profile, maybe call it some name that is representative of spectrum analysis. And I actually already have one created for the 421E that I'm going to show you this capability from. So if I drill into it, you'll see what's required to run this spectrum analysis feature. All that's required is that the radios, radio 1 and radio 2, in this 421E case, be set to a dedicated monitor. And so once that's set and you have the AP profile created, you can go ahead and go to the Manage AP view, go to where the 421E is at, and then just go ahead and assign it that spectrum analysis profile. And when you assign a profile, it generally pushes out a new configuration to that AP, and in some cases, it results in the AP going through a reboot. So let's go ahead and just give it a little bit of time to have that configuration sink in. You can see here that the 421E has gone offline, disconnected. So we'll wait a little bit for it to come back. It looks like it's back. So now we can go ahead and confirm that it is running the spectrum analysis AP profile. Its two radios are no longer broadcasting SSIDs. Let's go ahead and drill into it and get to the spectrum analysis capability. And all that is drilling down into more details on this access point and clicking on the spectrum analysis tab. And once you're in the spectrum analysis tab, you have the option to enable spectrum analysis on either the 5 gigahertz band or the 2.4 gigahertz band. And then you can, of course, in 5 gigahertz, you can choose the various channels that you want the spectrum analysis to be done on, and then identify whether the x-axis reports the megahertz values or the channels. Let's go ahead and take a look at 2.4 gigahertz and have channels 1 through 13, as well as have the x-axis display channels as opposed to the frequency. So you can see in this case, there's a number of different graphs or line graphs in this case, and spectrograms. The signal interference is a graph that shows what are all the interfering devices and the channels that they're operating on, and how strong, how loud they're actually communicating at. The amplitude shows the extent of how strong their signals are. And of course, you can actually see x-axis is channels, the y-axis is signal strength in dBm. Now there is a persistence indication that based on the different colors of these lines, it shows the frequency of their communications. So you can kind of get an idea here looking at signal interference that really more or less across the board, channels 1 through 13 is like utilized moderately. We're not really seeing a lot of green or red in this signal interference. So it's not, those interfering devices aren't really using too much of the spectrum. But for sure, there are devices across all 13 channels. No doubt about that. Now, if we look at the signal interference spectrogram, it really is just signal interference presented historically, within a 1 minute time frame. This is where you can see that across all of the 13 channels, we do get moderate use. There's definitely some blue and green here within the last 1 minute time frame. Duty cycle is the utilization of these frequencies. So we're definitely seeing high utilization. And then 1 through 8. So that seems to be pretty clear there. And of course, duty cycle spectrogram, similar to signal interference spectrogram, it takes the duty cycle and provides you a historical view. So like we saw how previously I mentioned 9 through 13 was more heavily used than 1 through 6, we can clearly see that here with a lot more red on the 9 through 13 side than from the 1 through 8. So lots of great detail with this spectrum analysis tool that is now enabled on our newer FortiAPs. Detected interference is how we're able to leverage the wireless signatures or characteristics of these interfering devices, and we can have the wireless controller provide estimates into the type of devices they are, whether they're wireless handsets, whether they're Bluetooth devices, whether they're microwave ovens, or even baby monitors. We would actually see a detected interference estimate or determination by the wireless controller through the spectrum analysis feature. So with that, that concludes my demo.
So what we'll do is we'll wrap this session up. I did see a bunch of questions in the chat log. What we'll do is send emails out with the answers later. Everybody that registered and attended this event will be receiving a recording of the session, so you can go back and review the new changes. If you do have any other questions or want to see or learn more about the Fortinet Secure Access product line, please don't hesitate to reach out to myself or Jim Wang or even your Fortinet local rep. Thank you so much, everyone, for attending, and we will go ahead and let you get back to the rest of your week. Take care.